Hello, class. This is the example for section 10.1 that I promised. The examples 2 and 3. Okay, so we're going to go to my MATLAB, my stat lab, and then do the those two problems on the homework. Okay, so that is here is the question, homework 10.1. And it says that sufficient, let's start from here. Listed below are amounts of court income and salaries paid to the town justices. All amounts are in thousands of dollars. Construct a scatter plot, find the p-value find the value of the linear correlation coefficient, the p-value using alpha as equals 5%. Is there sufficient evidence to conclude that there is a linear correlation between court incomes and justice salaries? Okay, based on the results, does it appear that justices might profit by levying large fines? Okay, so before we construct, this is when you are doing the correlation, the first data is your X, the second is your Y. So in this case, my X is the court income, my justice salary is what my Y. Okay, and then if you are testing test or hypothesis, the rho is always is a two-way. Okay, it's a two-tailed test. So the null and the alternative hypothesis is that the null is always equal to 0. So the rho equals 0, and then the alternative is not equal to 0. So this one will be the option A. All right. So to find the scatter plot, the correlation coefficient, and everything, we open this data in the StatCrunch. Okay. And then let's make it bigger, making sure that you are seeing that. Okay. Sounds good. And so I go to statistics and go to regression, simple linear. My X variable is my court income. My Y is the justice. All right. And you don't do anything. Okay. Test hypothesis. The rho has the same size as the slope. Okay. So in this case, the effect of the slope, okay, if it's positive, the correlation coefficient will be also be positive. So we're going to use the test saying that the slope equals 0, and then the slope is not equal to 0 for your null and then alternative hypothesis for this test. Okay, so you're going to compute, and when you do this, you have for the scatter plot, you got a p-value, you have the test statistics, the correlation coefficient. Here is the scatter plot. Okay, this is a scatter plot for that. And let's go to the second page. And then the first page is where we have the correlation coefficient, the p-value, and everything. All right. So here, the correlation coefficient is this value here. This is your regression equation. Justice salary equals that. And then this is the R squared is giving us that. And the test statistic, we're going to use that of the slope. This is normal. Okay, which is the 5.0 0158 whatever, and then the p-value is this one. Okay, so I can see the p-value is small. It's smaller than alpha, even if it's 1%. And so we're going to reject the null hypothesis and conclude that there is what correlation between them. Of course, look at the correlation coefficient, which is 88.4%. Okay, the net 78.2% of the salary is what is explained by the court the court income. Okay, so that means that if they increase the court income, it explains the justice salary by what 78 about 78%. Okay, so we have all this information here. All we need to do is that we can write these down, and we need the correlation coefficient, which is 0.8845 if it's to decimal place. So R, if my test statistics is there, it's what 5.0158 or 59, and then my p-value is 0.0015. Anything that we need is maybe the correlation coefficient, the equation, okay, which is you got the y-intercept is 26.979, and then the slope is 0.0387. Okay, so let's see what the question asks. So let's go back to the question, making sure that you are seeing that. Okay, so we have the scatter plot, as we saw, is what is going to be the D. Okay, that's the D is my scatter plot. My correlation coefficient is set to 3 decimal places, so that is 0.88885. Okay, and then what's my test statistic? Okay, test statistic is the 5.0 to 3 decimal places, so 0, 1, 1, 6. Okay, and then what's the p-value? This is to 3 decimal places, so that's 0.002. Okay, all right. So with this, say the p-value is less than 5%. Okay, therefore there is sufficient evidence to conclude that if the justices were leaving more money, then the court income gets more, then they get more salary. Okay, so that is it. And then, so what do you think? Based on the result, does it appear that justices might profit by levying larger fines? Yes, the answer is what, as we can see, since we rejected an hypothesis, okay, so it appears that justices profit, okay, by levying what? It does appear that justices might profit by levying larger fines. And when they do, they get more money. Okay, let's go to question number 3. That's another example. It said listed below are numbers of internet users per 100 people and numbers of scientific award winners per 10 million people for different countries. Construct a scatter plot, find the value of the linear correlation coefficient R, the p-value, determine whether there is sufficient evidence to support a claim of linear correlation between the two variables. Use alpha equals to 1%. So again, what we do is let's try a similar one. Let's try a similar, so that, because I already solved that one. So let's open this in the StatCrunch. Okay. Let's make it bigger, making sure that you are seeing that. Perfect. Okay. So we go to what? Stats, regression, simple linear, and then internet users is your X variable, and then award winners is your the Y variable. Everything stays the same there, and then compute. All right. So if we do this, when we compute this, we're gonna have what is our correlation coefficient is this. Okay, there's a correlation coefficient, which is that. So your R is 0.826 to 3 decimal places. Your p-value is 0.043, which is this one. Okay, that's a p-value. And then your test statistic is the t is 2.9226 to 3 decimal places. If you want to know the equation, it is the y-intercept is negative 8.7087. Okay, and then the slope is 0.2047. Okay, we're going to round it to some decimal place, but I wanted to make sure I have that. Okay, so test statistics is that, and then the p-value is this one right here. Okay, the scatter plot is this. Okay, so let's go back. Okay, and let's making sure that you're seeing that. Okay, good. Now you have what's a scatter plot. Okay, I believe it's the B. Okay, I think it's the B. Based on that, yeah, I got it right. And then correlation coefficient to 3 decimal places is what? 0.8826. And then, okay, so what is your null hypothesis? Is always the two-tail. So this is equal to 0. Okay, is equal to 0. It is not equal to 0. So it's always a two-tail unless otherwise we are told to do that. Either a right tail or a left tail. Okay, and then let's check that. We got it correct. The test statistic is set to 2 decimal places, and it's a 2.93. Okay, to 2 decimal places. Okay, and then p-value to 3 decimal places is 0.043. All right. Okay. Now, what's the p-value? Our alpha is what, 1%. The p-value is what? It's 4.3%. Okay. So it is actually greater. So there is not sufficient evidence. And if you check, that is the answer. Okay. So those are the two examples I wanted to do. All right. So that is N for that.